Alright, this is the beginning of acid-base notes. I don't know how many videos this is going to take me at 15 minutes a pop, so bear with it. If it may be where I load them up throughout the week as I go, so be patient with me. We're going to run through this. The first part of this is all kind of conceptual fun fact stuff about acids and bases, which is good, and then we get into the nitty-gritty of what that looks like equation-wise. So you have the notes available to you there on Google Classroom, so you can print them out and follow along if you want. Mine's just a printout copy that I'm writing on, so I even use color ink. Don't tell anybody, especially my wife. She'll probably be mad I used all that colored ink. All right, so here we go. This is acids and bases. Our first little slide here, properties of acids and bases. This is the properties of acids part. Aqueous solutions of acids have a sour taste. So they taste sour, and so you can start thinking about things that are acidic, right? So citrus fruit has citric acid in it. So you think about biting a lemon, that's that sour taste that you get out of it. Soda has phosphoric acid, has a sour taste to it. Acids change the color of acid-base indicators. You should know that pH paper, and you've probably already seen this, turns red. So pH paper will turn red if it's acidic, and it turns blue if it's basic. We'll see that a little bit down the line. So there's lots of different indicators. pH paper is kind of the go-to simple thing. That's one of those things where if there's a beaker sitting in the back and I'm not sure what's in it, I'll use pH paper to test to see whether it's acidic or basic. And then the third property says some acids react with active metals to release hydrogen gas. And we have done this several times during the year. So I don't know, we did in the most recent eudiometer lab with the big long tube that the acid came down and hit the magnesium. That was magnesium plus hydrochloric acid. That made hydrogen gas and magnesium chloride. We had the Penny lab, that was zinc reacting with hydrochloric acid. It reacted to form zinc chloride and hydrogen gas. Earlier in the year where we took the little pieces of steel wool and rolled them up, we dropped that steel wool into some sulfuric acid, and it ate all the steel wool. The steel wool went into solution as iron sulfate. We didn't know it at the time, and it bubbled, it released hydrogen gas. We did aluminum foil in hydrochloric acid at some point. This was the green flame that came out of the hydrogen gas that we produced. We were trying to show a different single replacement reaction with aluminum copper, but that produced hydrogen gas there. We lit it on fire, it had a green flame in kind of the bulb flask, and so there's several examples. It's active metals, right? There's an activity series, so that active metal has to be higher than the hydrogen that it's kicking out and replacing. But that's the third property of metals. So they create hydrogen gas when they react with active metals. And then you got properties 4 and 5. They happen to be the same properties as the base properties for 4 and 5. Acids and bases react to produce salt and water, always. That's a good one for us. You'll see that in some equations as we move forward. And then it says some acids conduct electrical current. It should say some, not same. I would say that they all conduct some kind of electricity. Some of them conduct more than others, but even weak acids conduct a little bit of electricity. So those are our last two properties there. Good, we've talked about binary acids. This is just a review of how to name binary and ternary acids, so I'll fly through this with us. This says an acid that only contains 2 different elements, hydrogen, and 1 more element is a binary acid. These are the guys that all start with hydro and they all end it with ic. So hydrofluoric acid is one of 2 things in the world that eats glass. Oh wait, some of you are thinking, what's the other one? And you've heard that joke before. It's me. I'm the other one. Hydrofluoric acid and me. That's what eats glass. HCl, hydrochloric. HBr, hydrobromic. If you ran into I don't know, iodic acid. It starts with hydro, ends with ic. That would be HI for the formula on hydroiodic acid. So that's how you name binary acids. We should be familiar with those. You can go back and look at those. Those 4 I gave you are pretty much the only 4. If you look at the PowerPoint has another slide that goes through all that stuff on binary acids, how you name them. And then the other ones we have are ternary acids. And ternary acids, I like to call them oxyacids. Oxyacids because they are hydrogen, which makes it an acid, bonded to oxygen and another element. So oxyacids, they all have oxygen in them, so it's hydrogen and more than one other element. Binary is just hydrogen and one other element. Oxyacids, hydrogen, more than one other, and usually one of those is oxygen. And this is the whole ending change. So when we look at HNO3, because it's an oxyacid, we cover up that hydrogen and we name the ion. NO3 is nitrate. And so we chop the ending, and the 8 ending goes to ic. This becomes nitric acid. If we had HNO2, we would cover up the hydrogen and name that ion. That ion would be nitrite. If it ends with an ITE ending, we change that ending to OUS. So that would be nitrous acid. It's just the back ends there that's switching. So cover the hydrogen, name the ion, change the ending of that ion. And you should be in good shape on ternary acids. Good, we've named them before. We named them in chapter 7, and you've seen them a bunch since then. The next one gives us common industrial acids. It's a great 1.5 pages in your textbook that kind of talks about the uses of all these, and so I'm going to give you the quick hitter little fun facts about these guys. But if you want to read through them, I think it's at least interesting to have a general idea of what these are used for. Sulfuric acid is the most commonly produced acid in the United States. Your textbook says 37 million tons a year. It's used in production of metals, and so they dunk metals into sulfuric acid because the sulfuric acid helps to get rid of any of the impurities off the metal so that the metal doesn't rust as quickly. It's actually an economic indicator. They make so much of it, so if the economy is doing really well, then or is going to do really well, there's lots of sulfuric acid being produced because anybody that's making anything metal needs sulfuric acid. So they can actually tell how the economy looks based on the sulfuric acid. If nobody's ordering sulfuric acid, they know nobody's going to be producing anything or making anything, and that tends to mean the economy's not doing as well. So sulfuric acid. Nitric acid, little fun facts, it dyes things yellow. There's a picture in your book of a feather halfway in and out of nitric acid. It dyes that feather yellow. We have a lab that we do where people come back and they have a yellow thumb. Sometimes that nitric acid will do that. It's also used in explosives. TNT, that N is a nitrogen part of that compound, and so it's used in explosives as well. Phosphoric acid used in fertilizers, animal feed. Dilute phosphoric acid is what's in your soda. If you have citrusy sodas, it's citric acid, but if your cola type sodas and your root beer type sodas are using phosphoric acid. Hydrochloric acid is it's usually used as a cleaner. It's a really great cleaner. I tell kids, my gold rings I clean off with hydrochloric acid. The gold's not reactive, and so the hydrochloric acid eats all that other junk out of the way and leaves the gold nice and shiny. And then the last one there, acetic acid, is the main component of vinegar. We did a sodium acetate supersaturated solution where that that chemical stacked up on itself, all that solid came out of that little bit of solution. It was sodium acetate. If you touched it, you smelled that vinegary smell on your skin. And the sodium acetate, that acetate ion, is what's providing that vinegar smell. It's used in the production of plastics, is the other thing acetic acid is used for. Then we are to the properties of bases. So properties of bases taste bitter. I always have people are like, I don't know what bitter tastes like. And so you did a mimicry lab in biology where they take baking chocolate and milk chocolate and they put powdered sugar on it and mix it all up in a bag, and you take one. It's a mimicry lab where you take one, you're like, ooh, milk chocolate, I'll have another. And then at some point you taste the baking chocolate, and the baking chocolate has a bitter taste to it, and it's gross. And so then the question is, do you want another one? And you're like, I'll pass. I don't want any more of that. I'm not willing to risk eating the good chocolate for a chance that I'm going to eat that bitter chocolate. So that's a good bitter taste. If you have a foul mouth when you were a kid, then your parents might have washed your mouth out with soap. Soap is a base, and so it's bitter tasting. I don't encourage you to go lick soap. But somebody will. Somebody be in the shower tonight, let a little soap get in their mouth. That's a bitter taste. I don't encourage that behavior. A lot of your medicine, a lot of times the pills that you swallow, Tylenol, has a coating on the outside, but if you don't get it swallowed in time, it tastes bitter. And I also don't encourage you to suck on a Tylenol for a long time, but a lot of times they have a bitter, basic thing to them to calm your stomach acid, to help your stomach feel better. So that if you try to swallow a pill and don't get it swallowed fast enough, you taste that bitter taste. Some of you have done that unintentionally. We talked about this a second ago. Bases change the color of pH paper to blue. The B's go together, blue for base. And then bases feel slippery. If you think about soap is slippery. If you ever do laundry and you get laundry detergent on your hands and you put it under the water, you can feel how slick it is. Bleach is that way, has a slick feel to it. Those are all bases. So bases tend to feel slippery. There's a question on one of the warm-ups that says, how do you tell an acid and base apart? You can feel them. You wouldn't want to stick your hands in them, but you could feel them, and the base would be slick on your fingers, where the acid wouldn't be. And then the last two properties of bases, and then we'll call that a good first video. I think there's 42 slides here. 38, there's only 38 slides. We're 9 in, so we're doing great. But these are the last two. I said they're the same as the acid one. Bases react with acids to produce salts and water. That's still true. And bases will also conduct a little bit of electricity. Good first chunk there. So that's kind of all the fun fact stuff. It's the first, I don't know, 5 or 6 pages of the first chapter. In the next video, we'll get a little farther into the definitions. What exactly does it mean if something's acidic? See you then.